Hi, M1 students. This is a key going over your Unit 3 quiz to review all problems that we did not complete in class. So if you would like to view the problems that we completed in class, feel free to pause and check them out, but we already did some of them. So in class we completed this table for number 2. Now let's go ahead and finish it up. Horizontal asymptote, remember, is a horizontal line always located at this back value. So for us in this equation is y equals 6. So we're going to draw a line in at y equals 6, and I always label my horizontal asymptote. Now we can go ahead and plot all of our pairs of points, starting with -1, 5 2/3, 0, 5, 1, 3, and 2, -3. So it's off the graph, but we know it's kind of down here somewhere. Remember that your horizontal asymptote is a line that your graph gets very, very close to but never crosses. So when we draw this up, we're going to get really close to the horizontal asymptote, and then we're just going to come right down. Okay? Your domain or your possible x values are all real numbers. We can plug in any x value and we will get out a y value. So this is all real numbers. However, your range has to do with y. Your y values are only existing below this horizontal asymptote. They will never cross above it. So we know that our y values are always going to be less than 6. All right, let's do number 3. Let's plug in for the -2. So I've got 1/2 to the -2nd power plus 3. Remember, that's the same as 2 to the +2nd power plus 3, which is 4 plus 3. We get 7. For an input of 1, we've got 1/2 to the -1st power plus 3, which is the same as 2 to the 1st power plus 3, which gives us 5. For an input of 0, we have 1/2 to the 0 power plus 3. And remember, any base to the 0 power is 1, plus 3 would be 4. And lastly, 1/2 to the 1st power plus 3 is 1/2 to the 1st power is just itself. 1/2 plus 3 is 3 and 1/2. All right, our equation of our horizontal asymptote is y equals this back component here, which is +3. And we can go in and draw a line, and we know this is going to be our boundary at some point in time. Let's plot our ordered pairs. So we've got -2, 7, -1, 5, 0, 4, and 1 over 3.5 up. So remember, with that horizontal asymptote, we are going to connect our dots in such a manner that they get very close to it, but they never cross. Now that we have our graph, our domain is always going to be all real numbers. We can take any value and plug it into our function, and we will get out a y value. But our range, we're never going to exist down here. This graph is bounded off by the horizontal asymptote. Therefore, our range is always going to be greater than 3. Okay. Determine whether the table of values represents a linear or exponential function. Okay, remember, a linear function has a common difference. My bad. Which means to get from term to term, we typically add, or we can even subtract. Okay? And we're talking about y values here. We're talking about the change in our y values, our output. And for an exponential function, we have a common ratio. And what this means is we multiply to get from term to term. So let's check out our first problem. To get from 12 to 9, 9 to 6, 6 to 3, 3 to 0, we're subtracting 3 each time. So this table represents a linear function because there's a constant rate of change. Which is the same as a common difference. Okay. Now over here, we look at our graph. How are these things changing? And I notice that 8 divided by 4 is 2, and 32 divided by 4 is 8. And then I check in 128 divided by 4 is 32. So I notice I'm dividing by 4. However, division is not an option up here. So I need to find a way to write this division as multiplication because that's going to help me later if I wanted to write an equation of this situation. So remember, dividing by 4 is the same as multiplying by the reciprocal, which is 1/4. So this indeed is exponential with a common ratio of 1/4. So this is exponential because there is a common ratio. All right. For numbers 5, A, B, C, and D, you're going to be plugging in these values and using a calculator if necessary. So let's see. Y equals 2 times 4 to the negative second. All right, so remember, if we have a negative exponent, we can flip the interior and make it positive. So this becomes 2 times 1/4 to the second power, which is 1/16. So we get 2/16 when we multiply those together, which can reduce to 1/8. All right, let's see. F of 3 equals -3 times 5 to the third. Orders of operations tell me I need to do 5 to the third first. And 5 to the third power is 125. Okay. And now I multiply by that number in front times -3. And I get an answer of -375. Okay, for this one, I've got 1.2 to the second power. I'm going to plug that into my calculator, and I get out 1.44. I have no number in front to worry about. Just plug it directly into my calculator because I don't know right off the top of my head what 1.2 to the second power is. All right, and for D, I have f of -2 here. 1/2 times 8 to the negative second. Well, in order to deal with that negative exponent, remember, I flip the inside and I make it positive. So now I have 1/2 times 1/8 to the second power, which is 1/64. And 1 times 1 is 1, and 2 times 64 is 128. So my answer here is 1/128. All right, let's get into these problems. Very important. Is this growth or decay? So we are dealing with exponential growth since our growth factor, which is inside the parentheses, is greater than 1. My initial amount is 0.75. That's my value in front right here. And remember, since this is exponential growth, what is happening inside those parentheses is 1 plus r equals 1.45. So how much above 1 am I? And the answer is 45%. That is my percent rate of change. To evaluate this when t equals 3, we need to first calculate 1.45 to the third power. and then we can multiply by the value in front, 0.75. And we would get, I forget what we're supposed to round to. We can round to 2 decimal places here. We get 2.286, which is 2.29. We did 7 in class together. For number 8, is this growth or decay? This is exponential decay. Since our growth factor is less than 1, our initial amount is this number in front right here, which is 100. And our percent rate of change, remember, inside this parentheses, since it's decay, I have 1 minus the rate equals 0.94. So I say, what did I have to take away from 1 to get a growth factor of 0.94? And the answer is 0.06. So our percent rate of change is 6%. When t equals 3, what does y equal? First, we're going to raise 0.94 to the third. And then we're going to multiply by the 100 in front. And we can round to 2 decimal places. So we've got 83.058, which rounds to 83.06. Question 10. A DVD company has a stock value of $22 and is dropping in value 12% each year. Write an exponential decay function that represents the value after t years on the stock market. Okay, so remember, exponential decay functions look like this. Y equals a, 1 minus r to the t power. And I just have to fill in what my a and my r are. My a is $22, my initial amount, what I started off with. And 1 minus 0.12, we need to write this as a decimal, remember, to the t is the same as y equals 22 times 0.88 to the t. What is the stock value after 4 years? We're going to plug in t equals 4 and evaluate. This is money, so we'll round to 2 decimal places. So y equals 22 times 0.88 to the 4th. Remember, we do 0.88 to the 4th first. We always raise our base to the exponent first, then multiply by the number in front. And we get 13.193, which is approximately $13.19. Okay, number 11 through 13 use this table. Number 11 says, determine whether the table represents an exponential growth function, exponential decay function, or neither. Explain how you know. Okay, so to get from 64 to 16 and 16 to 4 and 4 to 1, I notice I'm dividing by 4. Okay, and remember above we said that if we're dividing by 4, we need to switch it so that it's multiplication. And remember, dividing by 4 is the same as multiplying by 1/4. Now, in class on Friday, I told you to remember that your common ratio is the same thing as your growth factor. So that matters. So over here, I realize I have a growth factor of something less than 1, and also my values are decreasing. So over here, I would say that this is exponential decay. Since the function is decreasing, and my growth factor, or actually I'm going to say, you can say common ratio or growth factor. Oops. Is less than 1. So now that I know it's exponential decay, I know the structure of my formula looks like this. Y equals a times 1 minus r to the t. And I can just fill things in. Well, everything in your parentheses is your growth factor. And we said your growth factor is the same as your common ratio. The common ratio is 1/4, so we know that 1/4 belongs inside the parentheses. And just like a linear equation, our initial amount is when x equals 0. So we've got our initial amount right here of 64. Okay. What is the percent rate of growth or decay? All right, so since it's decay, remember what's inside this parenthesis is the same as 1 minus r. So we can say over here, 1 minus r equals 1/4, or 1 minus r equals 0.25. So what is my rate of decay? R is equal to 0.75, or 75%. Okie dokie, you guys have a quiz on this tomorrow. Hopefully this was helpful for you. Make sure you know your exponential growth and decay formulas. Make sure your notes are completed and you have this out next to you and your notes to help you during the quiz. Okay, bye.